At dawn, a new high-speed station opens beyond the edge of a small Chinese city. The platforms are ready, but most of the surrounding city has not arrived yet. A long silver train glides in with more seats than passengers. The obvious question is why this line was built here at all. But asking whether this single station is full may be the wrong question. China does not build high-speed rail as a collection of isolated trips. It builds the network first, then reorganizes movement around it. Distances that once divided regions are folded into a timetable. The railway does not only cross land, it manufactures usable time. A worker can now live farther away and still reach a major city before work. A family can visit another province and return before Monday morning. A supplier can attend a meeting hundreds of kilometers away and return the same day. A city that once sold locally can suddenly reach a much larger customer base. Specialized medical care becomes reachable without moving permanently. Students can move between campuses and families more often. A quiet destination can become a weekend market almost overnight. Before the passengers arrive, the station changes what everyone expects the city to become. By the end of 2025, China's high-speed rail network exceeded 50,000 kilometers. That network is longer than the high-speed rail systems of all other countries combined. The modern expansion began in 2008 with the Beijing-Tianjin intercity railway. During the 5 years through 2025, another 12,000 kilometers opened. High-speed rail now reaches nearly every large Chinese city. It serves 97% of cities with populations above 500,000. In 2024, high-speed trains carried nearly 3.3 billion passenger trips. Those trains handled more than 3/4 of all railway passenger trips that year. In 2025, China's railways carried nearly 4.6 billion passenger trips in total. Railway investment reached more than 900 billion yuan in 2025. That year alone, more than 2,800 kilometers of high-speed rail opened. By 2030, the official target is about 60,000 kilometers of high-speed rail. So expansion is not an accident left over from an earlier boom. It is embedded in national plans, local budgets, engineering schedules, and land decisions. Sometimes the railway arrives before current demand can justify it. The argument is that demand may grow after the line changes the region. This reverses the usual logic of waiting for traffic before building capacity. One new route becomes more valuable when it connects to many existing routes. A traveler may use one new segment as part of dozens of possible journeys. The value of a station is not limited to trips beginning in that city. A modest city can become important by sitting at the right transfer point. A short missing link can weaken an entire corridor. Once the gap closes, distant lines begin working as one system. China's core plan is often described as 8 vertical high-speed corridors. They are crossed by 8 horizontal corridors. Together, the corridors turn isolated routes into a mesh. A mesh offers multiple paths when one route is crowded or disrupted. Extra trains can be added where holidays or business peaks create sudden pressure. Even the schedule becomes a machine for coordinating thousands of connections. High speed is useful only when every junction, platform, and signal stays synchronized. Once the network exists, unfinished corridors become more visible and politically harder to ignore. Every unconnected city can point to the network and ask why it remains outside. Local leaders can see stations opening in neighboring regions. A missing high-speed connection can look like a future competitive disadvantage. Proposals, approvals, surveys, tunnels, bridges, and stations form a long project pipeline. A line may gather political and financial momentum years before the first passenger boards. Once land is cleared and tunnels begin, stopping becomes much harder. Local governments often support stations, access roads, and surrounding development. A station is rarely just a platform. It often anchors an entire development zone. Expectations of connectivity can raise land values before trains reach full capacity. Development can be financed by selling a future that the railway is expected to create. A new station signals that higher levels of government expect the region to matter. Manufacturers may value faster access to managers, engineers, and suppliers. Service firms can recruit from a wider labor market. Campuses become easier to integrate with regional research networks. Destinations gain visitors when travel time falls below a psychological threshold. A 2-hour trip can feel like a practical business journey. A 4-hour trip can connect major cities that once required air travel. High-speed rail is strongest when it binds dense city clusters together. Separate cities begin behaving like districts inside one larger region. Workers and managers can travel out and back without changing hotels or homes. On medium-distance routes, rail competes directly with airlines. Rail stations often deliver passengers closer to urban centers than airports do. Shorter boarding procedures reduce the time hidden around the journey. Rail can keep operating when some flights face weather disruption. The speed advantage is purchased with enormous fixed costs. Once laid, a railway cannot relocate when population or industry shifts. A lightly used train still requires crews, power, maintenance, and signaling. A quiet tunnel still needs inspection, drainage, and repairs. A bridge must be maintained whether 10 trains or 100 trains cross it. An underused station still needs lights, security, cleaning, and staff. High-speed rail works best when huge fixed costs are spread across many passengers. Dense corridors can fill frequent trains and support low unit costs. Sparse regions cannot create that volume as easily. Busy routes can generate operating strength for the wider network. The system can use strong corridors to help sustain weaker ones. A line can be socially valuable even when its direct financial return is weak. Connection can matter because exclusion has long-term costs too. Rail capacity can provide redundancy during storms, earthquakes, or road closures. A station can become critical on the one day ordinary traffic assumptions fail. That means the network is judged by more than ticket revenue. But social value does not erase the need to pay for construction and maintenance. The real question becomes how costs are divided across operators, governments, and future taxpayers. Ticket prices cannot rise without reducing the accessibility the railway was built to provide. Cutting frequency saves money but also weakens the network's usefulness. Some routes depend on future urban growth that may arrive slowly. If the local population shrinks, the forecast can move in the wrong direction. If surrounding development stalls, the station may remain isolated. A fast train is less useful when the station is far from homes and jobs. Some new stations sit behind enormous plazas that make human scale disappear. Meanwhile, the traditional city center may remain around the older station. The railway can split a city between the existing center and the promised center. Expansion also supports a vast domestic railway industry. Every new line creates work for steelmakers, engineers, builders, and software teams. Continuous construction preserves specialized skills that are hard to rebuild after a long pause. Train factories and equipment suppliers depend on a continuing project pipeline. Specialized tunnel teams become more efficient when they move directly from one project to another. Repeated construction also standardizes stations, signals, trains, and maintenance. Scale can reduce the cost of building each additional kilometer, but scale also creates institutions that expect expansion to continue. Stopping abruptly would strand workers, suppliers, equipment, and unfinished projects. Before one route opens, the next route is often already being surveyed. China is also preparing trains designed for commercial speeds around 400 kilometers per hour. Faster trains require better tracks, braking, aerodynamics, power, and control. New lines justify new trains, and new trains justify upgraded lines. The domestic network also acts as a showroom for Chinese rail technology abroad. Every reliable journey strengthens the image of the railway system. A serious failure would also damage confidence across the whole network. That is why control systems must become stricter as the network expands. As the network ages, China must maintain more track while still building new track. The first bill builds the network. The second bill keeps it reliable for decades. The current network is above 50,000 kilometers, and the 2030 target is about 60,000. That implies roughly another 10,000 kilometers in only a few years. Many of the densest and most obvious corridors have already been built. Future expansion increasingly reaches difficult terrain and thinner demand. Mountain lines require long tunnels, viaducts, and complex geology. Every added kilometer enlarges the system that must be inspected forever. Yet each added kilometer also increases the number of possible journeys. Expansion makes the system more useful and more expensive at the same time. The better the network works, the stronger the pressure to connect the places still outside it. Once near universal coverage becomes the standard, every remaining gap looks unacceptable. Back at the edge of the small city, the new station is no longer completely empty. A bus begins linking the station to the old city center. A small hotel opens beside the plaza. A manufacturer chooses land near the line. Workers begin experimenting with a longer but faster daily journey. The station is slowly turning its own prediction into reality. Some station districts will grow, others may remain expensive monuments. A national system can contain spectacular successes and costly disappointments at once. Ridership, profit, access, resilience, development, and national strategy point in different directions. Choosing another line is never only an engineering calculation. It redistributes time, land, opportunity, debt, and risk. Its costs begin now, while some benefits may take decades to appear. The next challenge is not simply building more, but using the existing network better. A route can become more useful when trains run at the right times, not merely at high speed. Holiday crowds can overwhelm a line that looks quiet on an ordinary weekday. Average ridership can hide the extreme pressure of national travel peaks. Some spare capacity functions like insurance for the days when the entire country moves. Better buses, metros, and roads can add value without laying another kilometer of high-speed track. Conventional rail can carry slower trips while high-speed lines focus on time-sensitive demand. The strongest system connects rail with aviation, metros, buses, and local streets. Housing and jobs near stations matter more than empty towers beside giant plazas. The useful metric is not the station facade, but the journeys it actually enables. Sensors and inspection trains can help manage a network too large for manual observation alone. The oldest high-speed lines are entering a period of deeper renewal and replacement. An aging population may change where, when, and why people travel. Remote work can reduce some business trips while increasing flexible regional living. Some routes may rely heavily on tourism that rises and falls with seasons. Extreme heat, floods, and storms add new demands to infrastructure designed for reliability. The real choice is not between endless construction and a complete halt. The harder task is deciding which missing links strengthen the whole network enough to justify their cost. A high-speed train cannot make a sharp turn once it is moving fast. China's railway system now carries the same kind of momentum. Cities, factories, workers, planners, and passengers now depend on continued operation and expansion. Building more is costly, but suddenly stopping would create costs of its own. The safest institutional choice is often to extend the system rather than interrupt it. Each new line completes an old promise and creates a new one. Each new station pulls another city into the politics of connection. Each kilometer makes the network harder to abandon and easier to extend. The true engine is not the locomotive, it is the system built around it. The small station now sits between an unfinished city and an unfinished national promise. Another train arrives before anyone can decide whether expansion has gone too far. The railway cannot stop expanding because expansion has become part of how the country organizes its future.